shall now discuss how to find median and quartiles in continuous probability distribution case. So here our topic is now median and quartiles when x is continuous random variable. So you know that median takes the 50% of the value. So therefore, if you integrate the given probability density function from lower limit to m, that is the middle point, then that will cover the area of 50%, that is 0.5. So when you integrate the function from a to m, you can say this is median point, then fx dx equal to, if you equate that, equal to 0.5, then the value of m you obtain by this method will be the median value for that function. Similarly, the first quartile takes 25% of the value, or also you can write that is equal to 1 by 4, and third quartile will take 75% of the value. You can also write it will be equal to 3 by 4th of the whole data. So the method of finding medians and quartiles are not different, only the difference in writing here. For the median we write here 0.5, for the first quartile it is 0.25, and for the third quartile it is 0.75. And just now we have learned about the cumulative distribution function, so that will be helpful in finding median and quartiles. Now here is one example. The example states that the continuous random variable x has probability density function given by fx equals to 1 by 8x. We have taken the same function from 0 to 4 and 0 otherwise. That means it is not defined for other range of values of x other than 0 to 4. And then in question number 1 we have to find the median of x, and in the second we have to find the interquartile range. So how do you find the median of that? So you can do in two ways. So just now you have learned about fx. For this function was x squared by 16, x squared by 16, and then if you say fx as fm equals to, then it is m squared by 16. That means here m is the median, and you know that median takes 50% of the value. That means in decimal, or it is 0.5 equals to m squared by 16, and then you solve it. It is m squared by m squared equals to 0.5 times 16. Okay, when you transpose this to the left, and then half of 16 is going to be 8, and now therefore m is equals to, take the calculator, then m will be equals to plus minus under root of 8. So plus minus under root of 8. So first of all we find the square root of 8. So the square root of 8 is, this is plus minus 2 root 2. So our median value is both positive and negative times 2 root 2. But what happens here, if you have look at this curve for x by 8, that is for x by 8, you can see that median, all the values are positive. That means also the range of values for x is less or equal to 4 and greater or equals to 0. That means median must lie between 0 to 4 only. So median cannot be negative in this case. So that is your median value is positive 2 root 2, and this is the answer. So in this way you can calculate the value of median by using the cumulative distribution function, cumulative probability distribution function. You can do this directly also. So directly, how can you do this? Actually, in alternative way, you can just try to write that integration from the lower limit is given as 0, and then it will go to highest value is 4, but we don't need highest value, we need the value in the middle of 0 and 4. So we write here m, and then this is fx dx is 50% or 0.5 or 1 by 2 as you need to write or as you like. And now it is 0 to m, and your fx value is x by 8. So it is 1 by 8 times of x dx equals to 1 by 2 to positive 2 root 2 is the median values. So in this way, you can also find the median of the distribution. And similarly, you can find the interquartile range. So in order to find the interquartile range, you should have values of Q1 and Q3 both. So let's find Q3 first of all, or you can find Q1 first of all, it doesn't matter. So your fx value was, you can see your fx value was here x squared by 16. So it is x squared by 16, and if you are going to find the first quartile, then you write here Q1, and then it is Q1. If you write here Q1, then it is going to be Q1 squared by 16, and Q1 takes 25% of the value, so you can write 1 by 4, and then this is Q1 squared by 16, so it is Q1 squared is equals to 1 by 4. If you transpose towards 1 by 4, then it's going to be 16. So 4 ones are and 4 fours are, it is 4. So therefore your first quartile value is plus minus 2, but you take only the positive value because x is between positive 4, 0 and positive 4. So negative value of Q1 is not valid here. Q1 can't be negative in this case. So therefore Q1 value is 2. So we have got the value for Q1, and now we shall calculate the value of Q3. So in order to find the Q3, you can just put here Q3, and to the right side instead of 1 by 4 you can put 3 by 4, or if you like you can just integrate the given function from the lower limit at 0 to Q3, and then fx value was 1 by 8x dx, and it is 75%. That means it is 0.75, or this is 3 by 4. You can do in either way. It should be between 0 and 4. So there is no negative values between 0 and 4. So therefore your Q3 value is 2 root 3. So therefore your interquartile range, you know that the interquartile range is Q3 minus Q1. Then write down the Q3 value is 2 root 3, and this is 2, so this is minus 2. And if you would like to have the exact answer, you can just leave it as answer, that will work, or you can simplify like this. 2, if you take out common, then root 3 minus 1, so you can express your answer like this also, if you would like to express your answer in exact form. If you write the answer in the significant figure, then you can do this also, then 2 root 3, and then it is minus 2, or you can calculate from here also, and that is equals to, let me write, it is SD. If I write, then it's 1.46 for 3 significant figure. So you can express your answer in exact form and also in a significant figure form as you like, or as it is advised in your question.